Hi, I'm Lauren Mullen, and I'm a senior scientist at Waters. My work is focused on the use of mass spectrometry in food and environmental applications, and I'm here to talk about how you can improve the efficiency of multi-residue analyses. Today, hundreds of chemical compounds are used routinely for crop protection around the world, and several new products are brought to market each year. At the same time, global trade is continually expanding. Given these industry dynamics, there is a critical need for rapid, multi-residue screening and quantification methods that can easily determine if regulatory limits are exceeded and the health of consumers is put at risk. Effective multi-residue methods rely on managing the acquisition of a large number of multiple reaction monitoring, or MRM transitions. By setting up overlapping MRM windows based around the retention time of each analyte, we can ensure that no time is wasted acquiring other transitions for compounds that have yet to elute. The shorter dwell time with scheduled MRMs maximizes sensitivity while ensuring a sufficient number of data points across peaks to yield good precision. To illustrate this approach, a method was developed for confirmation and quantification of 430 pesticides in chili powder using ultra-performance liquid chromatography coupled to a tandem quadrupole mass spectrometer. With this method, 2 MRM transitions for each pesticide were monitored, for a total of 859 MRMs, using electrospray ionization positive and negative modes. Relatively wide 1-minute acquisition windows were selected without any corresponding loss in performance. This eliminates the manual retention time check process and allows for easy transfer of methods between laboratories. The result is a greater workflow efficiency, both at the bench and enterprise level. The figure shown illustrates a portion of the more than 100 pesticides eluting between 9 and 10 minutes. Furalaxyl had an average peak width of 4.4 seconds and 10 data points across the peak for 3 replicates of the chili samples. Similar results, seen here, were observed for a second method containing 8 pesticides, where fewer transitions were monitored. So, despite the large number of compounds in our method, data quality wasn't compromised in the complex matrix. To assess the repeatability and robustness of this method, 300 injections of the chili sample were analyzed, as shown here. All positive and negative ionized compounds showed good percent relative standard deviations over 300 injections. Despite the large number of MRM transitions employing polarity switching, the method showed excellent reproducibility and quantification at a lower concentration in a complex matrix. I hope you enjoyed learning about how MRMs can be used to improve the efficiency of testing for food contaminants. For more details about this method, as well as the associated analytical technologies, download our latest application notes at the URL below. See you next time!